Hello all, welcome to part 5 of module 6, and in this video we will look at a very important concept called monitoring API calls. Now, why is this interesting? Whenever you look at malware analysis or reversing, it has a lot to do with how data gets passed around between different APIs, which of those APIs are called, and what they end up doing. So here is a simple example. If you're analyzing malware, you would be interested in what data the malware is sending or receiving over the network from its command and control. What are the registry keys it may be setting? Which files is it opening? Which files is it writing to? Many other things. This is where PyDBG comes to our rescue and makes API monitoring an absolute breeze. 3 simple steps. First is to find the address of the function or the address of the API you are interested in monitoring. Second, to set a breakpoint for that address. And third, once our handler is called when the breakpoint is hit, to dump the context, inspect data, read, write, do whatever we like, right? So let's go ahead and get straight to the action. Let me go ahead and open up Python. And let's open and create a new file. Save this. And let's call this monitor API.py. As usual, I'm going to import everything from PyDBG. All the defines as well. Now in this specific video, let's try something interesting. Let me import PyDBG in another terminal just to show you something interesting. So if you want to look at a list of all the running processes in PyDBG, let's run server strcopy as well. It's extremely simple. Oops. It's the most stupid mistake ever. Okay. Probably had the previous script in mind. And all we have to do is enumerate processes, right? And this is going to dump the whole list of processes to you. The one we are interested in is server strcopy.exe. So instead of having to find the PID every time of this process, this time let's just go ahead and do all of this in a more automated way, right? So here is what we are going to do. Let's say dbg equals PyDBG, and now for PID comma name in dbg.enumerate processes, this returns a list of tuples. If name equals, let's go back to the previous terminal. server-strcopy.exe. Now in this case, what you would want is to attach to this specific PID. So you would have dbg attach PID. Right, fantastic. Now, what is it that we want to do? Basically, this server, while it is communicating with our little terminal here, let me show you. This sends data and the server returns the data as well, right? So what I really want to do is monitor all of the send calls which our server is doing based on the data which it is receiving, right? That is exactly what I want to do. Now, in order to do this, the first thing, as I mentioned in the presentation, is to resolve the function name to an actual address where we can set a breakpoint for execution. How do we do that? Let's say send API address is dbg. Now there's a very simple method which is function resolve. Give the name of the DLL. Now send is going to be in winsock2. Name of the function is send. It's as simple as that. The next step is to set a breakpoint. So all we do is dbg bp underscore set, which is setting the breakpoint. The first thing is the address on which you want to set the breakpoint, which, as you can clearly imagine, is the send API address which we just found in the previous instance. The second thing is a description of the breakpoint in a human readable way. So let's call it send breakpoint. And finally, the handler, which we have not mentioned yet, but let's say we call it send underscore bp. Let's say that is the name of our handler. And then we basically need to allow the program to run so we can inspect it. Now going back here, let's actually define the handler function. So send underscore bp. And inside this, what we really want is to be able to inspect things, right? But let's first ensure that actually this is working. So let's say print send called, right? And because this is a breakpoint, you basically do not want to obstruct the program from doing anything. So you could just do a debug continue, right? Awesome. Now let's just go ahead and run this. Let me close this terminal. Hopefully I have put everything properly and this is going to work. Okay, so let me go ahead and bring up a command terminal. Let's go to the folder which we are interested in, which is code samples. And now what I want to do is run monitor API. Before that, let me run server str copy. I run the program and hopefully it's set the breakpoint, right? Now let me go back to my terminal and connect. Okay, awesome. Let's look at what's happening in the program right now. If you notice nothing, let me send some data. Hi, I get the response. And if you notice, it says send called, right? Let me send some more data. Hello. And if you notice, again, send call is received. The fantastic part is every time the send API is invoked, we are going to go ahead and hit this breakpoint. And now we have full idea about what is happening at that exact moment in the process. So let's improvise this program a little bit so that we can actually look at what is being sent and received, right? So in order to do that, let's go ahead and dump the context, so which will actually give you what's there in the registers on the stack, and then to some extent even the kind of data which is being pointed to by pointers on the stack. So let's go ahead, dbg, and the method is dump context, where you actually give it a context, and the context is dbg.context, right? Awesome. There you go. Now let's rerun this program. Come back here. Let's actually clear the screen first. Program is running. Let's go back to our terminal. We type in hello Vivek. Awesome, we get a response. And here you notice send called and context has been dumped. Now this context consists of all the registers. The interesting thing for me is to look at ESP, and if you actually notice, basically at ESP plus 04, sorry, at 08, we actually have a pointer which basically is pointing to hello Vivek, which is the data which the client just sent. Awesome, right? So if you notice, this is what this program is about to send back to the client. Now let's send something else. Let's say this is a demo for the SPSC, and the context was dumped again. It says this is a demo for the SPSC. Awesome, and it actually tells you that this address is lying on the stack. Now the best part about this program, let me just kill this, is if you notice the way the whole breakpoint and everything was written, it's extremely generic, which means I could just change the send to receive, and at least for this simple example, it just works out of the box. So now we will be able to monitor all the data which this program receives over the network, and whenever it calls the receive call, our breakpoint would be hit. So let me start the program again. There you go. And now let me go ahead and run this and say this is a receive demo. I go back, and now we are actually intercepting the receive API call, and receive and send typically have similar looking parameters on the stack. And if you notice, this is the string. This is a receive demo which was actually sent by the client which we are running here, right? And we were able to monitor the API, and now we are looking at actually what is there in the context. Now, as you can imagine, you have the power to look at everything in memory, even modify stuff in memory. Let's come back to our presentation. So what we learned was just fantastic, right? However, the output which was there was still a bit rustic, and hence the first exercise I want you to try is actually to read all the arguments of the stack for both the send and receive calls. So which means you create two breakpoints, one for send, one for receive, and then read all the arguments and print them out in an intelligible way, which is coherent with the API documentation for send and receive. So look that up on MSDN as well to understand what the documentation says. Now, the second thing is more interesting. To be honest, unfortunately, it looks like, from what I've been advised, I cannot distribute live malware samples for you to actually try them out. So what I'm about to do is give you an understanding of the framework you need to create, and there are dozens of sites online where you can download malware samples. It's just that I don't want to distribute it from our servers. So create API monitors for registry writes to things such as run on login, run on boot, etc. Figure out what those registry calls are and write specific API monitors, and then write monitors for opening and writing of files, send and receive on the network, and a couple of other things. And once you create the above monitoring framework, then run it against any of your programs which you may have or any other malware samples. I would really appreciate if you can create a video demo and post this on YouTube and then link it to SecurityTube and the student forum. That's all for this video. Hope you've learned how it is possible to now monitor API calls using PyDBG and which in turn will allow you to analyze the inner workings of any program. Thank you very much. Please post your questions in the students forum. Bye-bye.